Alright, welcome to today's lesson about completing the square. So you should open up your notes to this little section here. It says method 2, completing the square. This is building off what we were talking about yesterday, which is completing the square. And it has a bunch of steps here. If you want to read them, go ahead. But I'm just going to kind of explain it verbally. Here is pretty much the process. So you have this quadratic thing. And it's not really, well, this one's factorable, but we're going to forget that. We're going to pretend it's not factorable for a second. And the way the process works is you're going to take this constant term and put it on the other side. In this case, you subtract 32. And then you take this term, the b term of the quadratic, you take the b part, you cut it in half, and you square it, and you add that number to both sides. Half of 12 is 6. 6 squared is 36, so you add 36 to both sides of the equation. Negative 32 plus 36 gives you 4. And on the left side, you got this plus 36. The reason you do that is because this turns into two binomials that are the exact same. And so you can rewrite this trinomial as a single binomial squared. And so you get x plus 6 squared equals 4. And the benefit of that is you can then square root both sides. If you have something squared and you square root it, the squared part and the square root part cancel each other out, and you're left with just x plus 6. Convenient. That's not exponential anymore. That is linear. An important thing to remember, and when you do the square root and stuff, you square root both sides. And so you have to square root the 4, which gives you plus or minus 2. Remember, when you square root, there's two options. You can have a positive version or a negative version. And what that does is it makes two different equations. You got x plus 6 equals plus or minus 2. And so you got x plus 6 equals positive 2, and x plus 6 equals negative 2. Those equations are really quick to solve. You just subtract 6 on both sides, and you get x equals negative 4 or x equals negative 8. Let's jump over to another example here. This one's not really factorable because there are no factors of 8 that had to be 10. And so we are going to, at least integer factors. Anyway, so we're going to take this 8, put it on the other side by subtracting it over. And then I'm going to take this b term, the 10, the b number. You cut it in half, makes 5. You square it, you get 25, and you're going to add 25 to both sides of the equation. When you add 25 here, you're going to add 25 over here, which makes it 17. This part here, if you don't like the 5 squared part, you could put 25. This perfect square trinomial can turn into a single binomial squared. And that's because x plus 5 times x plus 5 gives you x squared plus 10x plus 25. And now we have this binomial squared. We can now square root both sides of the equation. The left side just becomes x plus 5. But the right side, the square root of 17 is not a nice number. It's a irrational number. It's infinitely long. It doesn't repeat in the decimal. And so we're just going to leave it as square root of 17. But make sure we put the plus or minus on it. That's an important part of it. And now to solve for x, we're just going to subtract 5. And what that does is it gives you negative 5 plus or minus the square root of 17. And I want to point out that this is two different answers. You get x equals negative 5 plus square root of 17. And x equals negative 5 minus square root of 17. So two different answers. It's just if you have the plus or minus there, it counts for both of them. So there's your answer. These do not combine because one's a radical and one's an integer. And so yeah, we're just going to leave them separate, and that's it. Those are your two roots, two answers. So that you've seen a few examples, if you want, you can kind of look through this one too, but it's the same idea. I'm going to go through these 3 examples here so you can see it in action again from scratch. All right, so first thing, I need to take this 59, put it on the other side. So subtract 59. And I'll get m squared plus 18m equals negative 59. I am purposefully putting a space here because I know I'm going to take this 18m. I'm going to take the 18. I'm going to cut it in half, and I'm going to square it. If you take 18, cut in half, you get 9. You square it, you get 81. So I'm going to add 81. That is not 81, that's 18, sorry guys. 81. And what you do on one side, you got to make sure you do on the other side as well. So I'm going to add 81 over here too. And what that does is it gives me on the right side here, I don't want to mess this up, and be totally embarrassed again. So negative 59 plus 81 is 22. This is a perfect square trinomial, and so I'm going to rewrite it. I'm going to rewrite it as m plus 9 squared. And if you're wondering where this comes from, like how I get this so quick, the number that goes here is this number. The inside part of, like, before you square it, half of the b value, that is what's going to be in here. And this becomes this. This is a substitution. I'm replacing it with something it's equal to, and so I can do that. Now that I have a binomial squared equals a number, I can square root both sides. It gives me m plus 9. On the right side, I'm going to get plus or minus square root of 22. This does not simplify. It's just 2 and 11, which there's no pairs of factors. So we'll leave it like that. Now my last step is just get my m by itself by subtracting 9. And now I got m is negative 9 plus or minus square root of 22. Remember, this plus or minus here does give me the two different answers. But yeah, there we go. I solved it. M is negative 9 plus root 22 or negative 9 minus root 22, which are definitely not nice numbers. But it is the solutions. It's the numbers you can put in to make it equal 0. Let's jump over to the next one. What you should do is see if you can do it all by yourself. Go ahead and pause the video. Give it a shot. All right, let's dive in. First up, get rid of the negative 85 here by adding 85 to both sides. Now I got k squared minus 4k. Oh no, I want the 4k back. And equals 79. I'm going to take this negative 4 here. I'm going to cut it in half and square it. And that goes here and over here. Negative 4 cut in half is negative 2. Squared is 4. So I'm going to add 4. Over here, I'm going to add 4. And that gives me k squared minus 4k plus 4 equals 83. Now I'm going to take this part here and turn it into a binomial square, which is k minus 2. Because negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is the negative 4 there. And the right side is still just 83. But now I can square root it because it's a binomial squared. So I get k minus 2 equals plus or minus square root of 83. 83, is that prime? It's probably prime. I think it's prime. Anyway, I'm going to add 2 now to move it over. And I got k is 2 plus or minus root 83. Voila. Answer. Nice. Let's jump over to the next one. This one's a little bit tricky because it's got this 5 sticking out front, and that matters. You have to do something with it. But we're still going to do our first step. Let's move the 7 over. And now we got 5b squared plus 10b equals 2. And from here, before you take this 10 and cut in half and square it and stuff, you actually have to get rid of this 5 first. So I'm going to divide everything by 5. And that gives me a b squared plus 2b equals 2/5. And yeah, I'm just going to leave it like that because I kind of have to. But now I can do my completing the square part. I'm going to take this 2, cut it in half, square it. 2 cut in half is 1. And when you square 1, you get 1. And I'm going to add it over here too. Add 1. And now I got, I'm just going to rewrite this as a binomial squared. It's b plus 1 squared. On the right side, we're looking at 7/5. And you can test that on the calculator if you want, but I'm feeling pretty confident about it. Now we can square root and get b plus 1 is the positive or negative version of the square root of 75. And we're going to subtract 1. And now we got b is negative 1 plus or minus the square root of 7/5. Ta-da! We did it! That's it! That's it! And I want you to realize how cool and calm I was with the fact that there was a fraction on this right side. It's okay if there's a fraction. You just deal with it. You can use a calculator. It's great. It'll calculate things for you. Like if you had a hard time with 2/5 plus 1, you just use a calculator. It'll be great. You can use a calculator to help you convert fractions and stuff. So there you go. That's how to complete the square. You got 3 lovely examples that weren't already on the paper for you. Go forth, conquer, do awesome on your assignment.